Hi, it's Terry Dennery of the MathWorks. So here's exactly where we left off on the previous video. So let's run this. It looks really pretty good for, I think, about a second and a half. So let's bring it. Yep. Yeah, it looks like it's perfect. Okay. Just joking. All right. And so anyways, the basic idea, I kind of went into this in the previous videos, that if we really know the mechanics perfectly and we tell it, precisely how we want it to move, we can be very accurate in calculating the torques required to do that. And that's essentially what we're doing here. Okay. Now, the key is if we can be really accurate, well, what does that mean? Well, it means really, really accurate. And in the case of essentially, I think it's something like 4 links, it's sort of like a quadruple inverted pendulum. The instability is incredible for that problem. And so even with this kind of idea that we're running this on the computer, that both models are mathematically identical as far as we can tell, that it's still not going to match, that this instability will take the difference between the two. What's the difference? Well, it's a calculation. It's kind of, you might say it's the machine error. It's something like 10 to the minus 16th. So 10 to the minus 16th for an unstable system like this will grow pretty rapidly and soon, very quickly. What you think it is, which is what I'd call our prescribed motion model, can be very different. It can depart substantially from what we're kind of modeling as the reality, which will be our plant model. Okay. So anyways, just to prove that point, I'm going to do this. I'm going to go in here. I'm going to introduce a multiplier. I'll just call it gravity. But ultimately what this is number of G's. I'll still call it gravity multiplier. All right, so that's a MATLAB variable. Control C. Oh, and I need to put the multiplication sign in there. Okay. Okay, notice the block's pink now because it doesn't know what gravity multiplier is. So I'll just go in and put it into my workspace, and I'm going to make it equal to 0. That's my quick way of making gravity disappear. So I hit enter like that, and again, that's all taking place in this block. This is an identical block, and so I'll just delete that one. I want each of them to have their own copy, but this one's now defined with that gravity multiplier. And so I'm going to hit run. And look at that. Isn't that awesome? So this one's driven completely by torques right here on the right that are calculated by this, the simulation, the prescribed motion simulation of this way. Okay. So that is kind of cool. But again, we know gravity multiplier is actually equal to 1. That's what we're going to be designing for. And therefore, with that return, I'll just kind of run it again to show that the instabilities will get you. There goes wrong again. All right. So, but what we're seeing here is kind of the basics of, I think, any control system. And so I'm going to do a little bit of redecoration. Maybe I'll move this up like this. Okay, I'm going to do this too. Let me introduce a constant block. So we'll make this 0, 0, 0. All right, so that's basically position, velocity, acceleration for something that does not move. So that's our bicep PVA, and we'll do that for the hand as well. And so with that, then I want to do this. Just take all of that, throw it into its own subsystem. I'll call it CMD for command. And then the rest of this, well, that's my control. All right. Oh, I didn't get this. Thought I did. All right. So all this, of course, then that will be our plant. So let's create a subsystem with that and kind of line it up. All right. robot plant model, so we can design with simulation. Let's call this control, and then we got CMD right there. All right, and let's make it a little bit bigger. So go to format and match the height. And let's do the same thing in this. Okay. All right. So what's bugging me now is all these lines. And so, anyways, I want to kind of deal with that. And in a way, I'm going to explain why we even came up with buses. But certainly this was a big motivation for it. Managing all these signals can be, well, I'll just say it can be really important if you can do it effectively. And buses help quite a bit with regard to that. All right. And so it means that these 5 that go in and out of each of these blocks, I want to turn them into 1. And the buses are real good at doing that. All right. So let me just kind of delete all that. Okay. At first, I thought I'll kind of get into this, but in a way, we're going to do something a little bit different. But let's go bus creator. Okay. And so I got all cranky about this. I go, hey man, it's calling all of them the same thing, torque. Okay. And that's because we're really taking a signal out of a bus. And so the way you do this actually is send in the whole bus. And so I'll go in here. I'll put these first 2 in. You'll see that when, oh, they're not called anything yet. So let's do the whole thing where you name them, right? And so this, I'll just call TTM for measurement. This one we'll call B_M. And so those names now kind of describe it. And you'll see that because it's the name of a bus, the bus itself then shows up. So the hierarchy is kind of retained, and definitely like the way they did that. All right, so let's just kind of finish this up. Again, a nice feature. You got a signal going into a block where all the ports are already used. All you got to do is bring it up to it, and it'll create a new port for you. So we'll get that in. And this one we'll call FA. M. This one we'll call WM for wrist. And then this for the hand, we'll call HM. So that'll be an out. So we'll send that into, and we're in the controller, right? And so, I wanted to call it torques, but I'll just call it control at this point. I think that's fair enough. All right. And so on this side, instead of it being a bus creator, well, of course, we'll use bus selectors. All right. Oops. Oh, here's my undo button right there. All right. So we'll delete that. And so let's get a bus selector. Oh, this will be a little bit hard. Okay, and so here's the thing about buses. Buses are real good if you got your signals figured out, and then it does stuff like this and says, oh, I see what's coming in. I'm going to give those names, and you're going to access it and all that kind of stuff. But this has nothing coming in, all right? And so I'm going to just kind of leave it like this for right now, but I am going to set up the interfacing, and so I'll bring in an in block, all right? And so this is going to be essentially the motion command. We see the PVAs and all that kind of stuff there. So I'll name it at least CMD. All right, and that's exactly what I wanted to get to, which is single inputs and single outputs. So anyways, let's delete that. And I guess we'll go in here next. Actually, you know what I'm going to do is I'm going to just shut up as I go through this, and I'll kind of edit out all this stuff, because really what I'm going to do for these next two blocks is no different than what I just did for this one. So I'll edit it out. It'll be more interesting for you that way. Okay, so I just did a ton of work, edited it out, and this is kind of where we are now. So basically single inputs and single outputs. And with this, we got a little bit of work to do still, but basically we can set it up like this. Right. And with that, now I can kind of get the finishing touches on this motion command, because it's receiving a signal that I set up for in my command system. And so I see the turntable, bicep form, all those axes are available now. And so we'll select all that. Yeah, got it. And all those line up. T, T, B, F, A, W, H. Good. Right, and I'm going to steal this, because it's the right size for what I'll use here. Okay, but all those names are wrong. I am not sending commands in here. I'm going to be intending to send torques. So we got a little bit of work to do. All right, and so robot control, just to remind you, is the signal that was set up here with this bus creator. Right. We're going to say, I don't even have access to anything that's got names like that. So let's get rid of all those. And now let's go get the torques off of each of these. And we'll do these one at a time. So get the turntable torque, bicep torque, the forearm torque, and then the wrist and the hand. Okay. Kind of wish it would say on the signals those names, but at least we can go in here and kind of see that we got off the right, I'll call base, turntable, motor, the motors in general. All right, and so I'll hit run. I'll run from here. Again, it goes crazy because of the instability that's introduced by the gravity. And if you really want to see it work well, then you can shut off gravity like that. Animation up there. Okay. But of course, in general, there is gravity. I'll just kind of wrap up on a few things here. Usually my command block is smaller than the other two, and usually I have a feedback loop. All right, just kind of at least introduce the idea of the architecture of what it's going to look like. And it's through here that we'll have measurements that will be the basis of some feedback control, which we're going to issue with the PID algorithm. So anyways, thank you.